Now that we have confirmed the line of communication from pawn to widget and back, we can set up the remaining user settings. Let's get started. Open WP User Hood. It's located in our Darts folder, UI, UMG, Hood, WP User Hood on the right. We're going to open the assets we want to modify from here. Select WC Hood Locomotion, which is what is being displayed now, and click Edit WC Hood Locomotion at the top right of the Details panel. First, notice that the vignette options are all grayed out. This is because the vignette options only apply if locomotion is set to standard controller movement. Before we start with the menu as a whole, let's get the individual buttons working. Select any button and click on Edit W_Settings button. We'll need to be able to visually see if a button is active or not. In its current state, with the border showing, we'll keep this as the active look. When it's inactive, it will have no border. We need to create a few variables here. The first is named button action of type eButton action. Create another named button text of type text. And a bool named button on. Just going to place these into a settings category for organization, and I'll compile. Set all three of these variables as instance editable. Now, create an event pre-construct and an event construct. The event pre-construct is much like the construction script in an actor blueprint. Also, create a custom event named setButtonOn with a bool input named buttonOn. From buttonOn, set the variable to buttonOn, then get a reference to the image border. Create a setVisibility node, and from inVisibility, create a select node. On false, set to hidden, and on true, set to visible. On event preconstruct, get a reference of text block text and plug our button text into inText. And plug that into our event preconstruct. Then call setButtonOn. Plug our buttonOn variable into the bool input. Notice how it says new param here instead of our variable buttonOn. This is just because the blueprint hasn't had a chance to update yet. So if we press compile, it's going to give us an error. But if we right click and select refresh nodes, you'll see that it now says buttonOn. So recompile again and all good. Lastly, from the event construct, pass on our button action value to our W core button. Open WC Hood Locomotion and we'll find everything sort of gone. This is because, of course, none of the buttons are active, which means all of the borders are hidden. I'm going to select the button on the left and set it to Locomotion Teleport with teleportation in the as the text, and I'm going to keep it off. Our button has immediately taken the values and applied their effect. Let's do the rest of the locomotion folder. So the next button is the locomotion controller, and we'll type standard controller, and we'll also keep this off. So vignette screen on rotation, will be the vignette screen on, and we're just gonna write on here. And then on the right, we'll write vignette screen off and write off. Reopen the graph and create a custom event named setLocomotionMethod with a bool input named teleportation. Get a reference to the settings button teleportation and the settings button standard controller. First, call setButton from the teleportation and plug the teleportation bool input directly into buttonOn. Then add a not node and plug the result into button on for standard controller. Get a reference to the vertical box vignette. We have access to the vertical box because we've set isVariable to true. Anything we do to this panel will affect the children within. From vertical box vignette, create a set render opacity and a set visibility node. We're going to be using the set render opacity to change the opacity of the widget and the set visibility to allow it to be clicked or not. From in opacity, create a select float node, set A to 1 as in available and B to 0.1 as in unavailable. Plug the result from the not into pick A. From invisibility, we'll also use a select node and using the value from the not. For true, as in it is visible, we're going to set this to not hit testable self only, and for false, as in it's not visible, we're going to set to self and children. This will allow the box to be visible to us, but not be used by any input, including the widget interaction component. We should also add a function to an event construct so all the default values are properly set. So create an event construct. From there, get and cast to our game instance darts. Get a reference to our struct VR player settings and create a break struct node. Show only the relevant variables. For now, those are eLocomotion method and vignette screen on rotation. Now we're going to plug them into the proper events. So we'll call set locomotion method, and we're going to check if locomotion method is teleportation. So we're going to create an equals enum node as teleportation and plug in this in to teleportation. We will use vignette screen rotation by setting the active on or off for the vignette. So if I bring in the W settings button vignette on, I need to set the button on. And if vignette settings are on, plug that directly into button on. And we're going to do the same logic where we'll create a not node and plug that into the vignette off. Just like so. While this part isn't technically necessary, it allows us to modify the defaults without worrying about our UI reflecting those value changes. Return to WP user hood and drag a reference to WC hood locomotion into the graph. From the hood locomotion node, call our set locomotion event and plug them into locomotion teleport and locomotion controller, setting the teleportation bool appropriately. I had forgotten to make the set vignette on screen event, so I'm going to go ahead and create that. Set vignette on rotation. The same way we handled setting the buttons on or off for the teleportation, we're just going to duplicate that and plug in our vignette off and our on. We'll compile this back in user hood. I will call set vignette on rotation, and when I turn it on, I'm gonna set button on to true, and then I'm gonna set button off when I turn it off. That's all easy, right? These are our locomotion settings. So I'm gonna compile. We could test now, but I also want to see the change happen in the pawn. From the E button action, get a reference to our struct VR player settings variable and create a set members node. Set the appropriate members to the correct settings. We'll need to set the locomotion method, one to teleportation and the other to standard controller movement. We'll also need to do the same for vignette screen on rotation, both true and false. So let's quickly set these up. Locomotion teleportation. I'm going to duplicate this and change this to standard controller movement and plug that into the controller event, the controller execution. I will duplicate this again, hide locomotion method and show vignette screen on rotation. Plug that into vignette screen to on, turning this on, and then dragging off to off. And I'll save that again. Now we can test. So right now I'm able to teleport. So teleport must be the default. I'm going to bring the menu up, change to standard controller, and I'm going to try teleport, and I am unable to, but I can walk around. Okay, so awesome. But let's see, can I change back to teleport? Open the menu. Let's change vignette screen on rotation. So I'll turn that on, and if I rotate, there we go. Now our screen is rotating on now our screen is vignetting on rotation. I'm going to open the screen again, change teleportation. The vignette options turned off, and I'm unable to interact with them, and I can teleport again. Awesome. So that all works, but I don't really like that we could still teleport while changing settings. Open the macro locomotion method we created earlier. Add a branch and plug our user hood visible bool into the condition. On false, continue, but on true, do nothing. On false, continue. On true, do nothing. And compile. Okay, let's test again. So now I could teleport, but if I bring up my menu, I can no longer teleport while the menu is visible. If I hide it, now I can teleport again. Now that we know how to set up and communicate the toggle buttons, the buttons that turn something on or off, let's move to a menu with a slider. Open your WP user hood and select Hood User Interface to edit. While we're here, we can of course set up the placement of the UI. Set the left button under placement to hood and the right to on hand. An action to UI type hand. Copy the event construct from locomotion and paste it in this graph. We'll again need to retrieve the defaults and set them shortly. Change the revealed variables in the break node to E user interface type, UE interpolation speed, and E HMD mirror mode. Just like we have passed along logic from our buttons, we'll now do the same with our sliders, but for these we'll also have a value to communicate. Return to the Designer tab and select the slider to edit, and edit widget. Notice that there are two images inside an overlay. One is the border and the other is the color to display. Again, try to build as many reusable assets as makes sense. Sure, this initial setup is taking a while, but when we're done, we can expand on it and add 20 additional settings in 10 additional menus, and the setup would not only be much faster, but the look and feel and style of the project would remain consistent. Then when we receive an update that the handle on the slider needs to be an orange square instead of the current white circle, it's only one change to be reflected throughout the entire game. Back to the slider. Open the graph. We need to make 6 variables to make sure this works throughout our settings. Create 4 float variables, name them min value, max value, current value, and step size. We need to make a bool variable named isColor and our button action variable. I'm going to place them in a settings category just to keep everything as organized. Set all the variables to instance editable and compile. Even though there's no core button being used here, we will still use the same button action to tell the pawn and hood what the slider is trying to change. Create an event preconstruct. We'll set all the constraints and settings of the slider here. Get a reference to the slider. From slider, create the functions set min value, set max value, set step size, and set value. Then plug the variables with the same names in. I'm going to plug min value into set min value, max value into max value, whoops, max value into max value, and step size into step size. Okay, lastly, we're going to do a set value and plug current value into there. Next, create a branch with the condition of is color. From true, set the visibility of text block value to hidden. And from false, create a set text for text block value, and then set the visibility of image color to hidden. Drag our current value into in text. It will automatically create a toText node. Expand the options and change the maximum fractional digits to 1. This is simply to format the value of the float, so if the real value is 1.8273, it will only display 1.8. Select the slider and create an event on value changed. Immediately set the current value from the new value. Then get and cast to our BPP pawn darts. Call the UI core button pressed event and split the struct. Plug in the button action and from current value create a round node to convert to an integer. We can also now plug directly our current value into the value float. To convert the float value to a hue of a linear color, we need to plug the float into an HSV to RGB linear color node. Right-click and search for HSV to RGB linear color. Split the HSV struct. HSV, or hue saturation value, are handled in Unreal Engine using the following scale. The S and V are identified from a 0 to 1 float value. Hue is the traditional 0 to 255 scale, 0 being red and 255 being red. All other hues live somewhere in the middle. Plug in the current value into HSVR, set G, B, and A to 1, and plug into the value color. Create another branch based on is color. If true, set the color and opacity of our image color to the result of the new linear color. And if false, set the text the same way we did in the preconstruct. Don't forget to make sure that we change the maximum fractional digits to 1. Lastly, we need to create a custom event so we can update the value to its default. Create a custom event named force change value with a float input named value. Now that we have the value it should be, we need to tell the slider to place the handle at that location. Get a reference to slider and add a set value node. Plug in the current value. Finally, plug the set value into the UI core button pressed event from BPP pawn darts. Return to hood user interface and we'll set these sliders up. In the slider under UI interpolation speed, set the max to 5 and the step size to 0.1. Also, make sure to change the button action to UI interp speed. For the HMD mirror mode slider, set the max to 5, the current value to 5, and the step size to 1, and the button action to HMD mirror mode. We need to set the button on value for the user interface and change the text to currently chosen HMD mirror mode. Create a custom event named setUIPlacement with a bool input named hood. Just the same as in the locomotion widget, set the hood button on directly from the hood input from this event and create a not for the on hand button. So we're going to drag from settings button hood and set hood button on from hood. And we're going to call that same function, but from the on hand widget. And create a not Boolean. Create another custom event named setHMDMirrorMode with an integer input named HMDMirrorMode. We're going to convert the integer that is provided from the slider into a byte and that into our eHMDMirrorMode enumeration. Get a reference to our text block HMD mirror and create a set text node. And we're going to plug it into HMD mirror mode. Drag from the integer and search for byte. Then from the byte, search for eHMD mirror mode. If we tried to connect the return of the eHMD mirror mode into text, we would be unable to. However, we can convert it to a string and then convert the string to text, but be certain we are converting the enum to a string and not the byte, as it will provide us the option for both. From eHMD mirror mode, search for enum to string and plug that into the in text. We just need to set up the calls in the pawn and BP hood just as we had done for locomotion, and we could test all of this. Open our motion controller pawn darts and set the members of our VR player settings the same way we did for locomotion. Create a new struct to keep organized. So what's first? A hand and then hood. For HMD mirror mode, replicate the same logic we did in the widget by converting to a byte and then convert the byte into eHMD mirror mode. And we converted that to a byte. I could put the byte directly into eHMD mirror mode. And just to be sure that this is a byte to enum eHMD mirror mode. After setting the mirror mode, we need to call the function setSpectatorScreenMode. Connect the byte directly into convert to eSpectatorScreenMode. SpectatorScreenMode. And we're going to plug the byte again into our setSpectatorScreenMode, and that is an enumeration of itself named eSpectatorScreenMode. And this is the actual function that's going to give us the change we're looking for. Our eHMD mirror mode is in the same order, so this will handle nicely. And by that I mean the enumeration that we had built previously under Dart's development enumeration eHMD mirror mode. This is in the same order that it is set inside of the function. So we don't need to worry about using these values, as we can use the byte converted from the integer to handle that for us. Oops. Now back to WP user hood. Drag in a reference to the user interface, and we only need to call the set UI placement event and the HMD mirror mode event. The UI placement, which is the hand. So, and then for hood, I'm going to set hood to true. Set HMD mirror mode and put that into here and get our temp value, split the struct, and plug the integer in. We won't fully set the player color slider up to change the material, though the material the mesh has on it is completely ready to handle that change. Let's just have it change the color of the image in the menu. Open WC Hood Player Settings and select the Player Color slider. Set the min to 0, the max to 255, and the current value to 100 or so. The step size should be set to 1. Set isColor to true and set the button action to Player Color. I'll also disconnect our print string node in Motion Controller Pawn. Compile and press play in VR. What you see right now is the single eye cropped spectator screen. But if I open up our menu and using my right hand, I'm going to go to the right to user interface, and I'll change HMD mirror mode from single eye cropped to single eye. And now what you're seeing is the single eye distorted. It shows the two eyes undistorted, single eye letterbox, and then of course disabled, which could save a lot with performance if you don't need to be showing it on the screen, because then it doesn't need to render again. Because these all take some time to set up, I'm going to leave you with these. All the rest can use the exact same logic to set up, as they all use the core button or the slider. Take what you learned here and expand on these settings. There is a fine line between a good amount of settings and too many settings, but generally, giving your end users options is a great thing. In the next module, we're going to use UMG for our Dart Games scoreboard.